So this is a lecture on how to find where an earthquake actually occurred. And I know that we've seen this, you have seen this in class already a couple of times, but I want to show you this again and kind of connect it with where ultimately we find out where an earthquake occurred. And we want to find out the epicenter. And again, the difference between the focus and the epicenter is that the focus happens exactly where the earthquake happens, underground, and then the place on the Earth's surface that's directly above the focus is the epicenter. So we want to find where that center happens, where the earthquake happens, but we can't find it normally because they're random. We don't know where they are. So we need to use the earthquake waves to help us. And one of the things that we'll see, as we've talked about in class, the P waves arrive first, they're the fastest waves, the S waves arrive second. There's a time difference between them. And if we look at an earthquake like this, there's an earthquake that happens in Denver, St. John, and Lima. The time difference between them changes as you get further away from the earthquake. They get more spread out. And we're going to use this time to help us find where that earthquake happened. So and I'm going to show you how to do that. So this is when I'm asking you the questions after the video, this is one of the things I want you to be able to explain in your own words pretty clearly, I hope, how you use the earthquake chart, the S&P wave chart, to help you figure that out. So we know that when we have a seismogram, the time difference between when the P wave arrives at the station and the S wave arrives is a certain amount of time. Depending on where you are, that time may be different, but we know that a certain amount of time has gone by. To figure out where that earthquake occurred, we can use that chart on page 11 in the reference table. So first you have to find the time difference between the S wave arrival and the P wave. So the time difference between when the P wave arrives and when the S wave arrives. After you do the math of subtracting those, let's say it's 7 minutes here. Time difference of 7 minutes, we know that on this chart, this is your P wave arrival, and this is the time that the S waves take to travel. So if I can find where the P wave arrived and where the S wave arrived and where that time is 7 minutes apart, those two curves are 7 minutes apart, then you can find the distance to the epicenter. So what you do is you take a little scrap of paper, you mark off 7 minutes, mark the 0 point and the 7. You take that and you slide it onto the curve and see where those two match up. You'll slide it back and forth until you see that this is exactly 7 minutes apart. And if you look right here, this is 20, 40, 60, that's 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes, 7 minutes, right here at this line. So it should be follow that down, and it should be right there at 5,200, 5,400. So it should be 5,400, sorry, 5,000, that should say 400, sorry, should say 5,400 kilometers. That's how far away the earthquake was from that city. Now, once you have that information, once you know that, you can find that information and use that to help you figure out where the earthquake was by doing this. So we know that the time differences, again, this is just a different way to show that, using the S wave and the P wave, where those two were 12 minutes apart here, or let's say 8 minutes apart, or 3 minutes apart. You need at least 3 seismic stations to help you find where that earthquake occurred, because when we draw a circle around that location in Denver, if we draw a circle around Denver, then we see that the earthquake could have happened 2,000 kilometers away from here. It could have happened anywhere on that circle. The earthquake couldn't have been any further away, couldn't have been any closer, because the time that between when the S wave arrived and when the P wave arrived was 2,000 kilometers. We know that for St. John's, it could have been at any of those any point along here. But because I know that St. John's is this distance, I know that Denver is this distance, and I know it's 9,000 kilometers from Lima, we know that this has to be the location of the earthquake. If you only had 2 seismic stations, you would have 2 points where that earthquake could have occurred. So you need to measure with your scale, measure using your compass to draw a circle around the cities at the exact location, that exact distance, I should say, and then you know exactly where that earthquake happened. So in your own words, in the questions that I'm going to be asking you after this video, I would like you to describe those steps on how you do that so that you can sort of see where we get this information. Because this information, this 2,000, this 5,300, this 9,000, we have to go all the way back to these seismograms to figure that out. We're looking at the time difference between these 2 waves, how much time there is between the S and the P waves, and that's what gives us the information. Sometimes that's called the lag time, sometimes that's called the time difference between the S and the P wave, the time lag, or the difference between those. So that's how we refer to that when we're talking about these in these questions. So hopefully that helped to clear things up if you're still confused. If you're not and you know it, that's great. So hopefully this is pretty straightforward. So answer the questions on the in the survey so that you can get credit for this homework assignment.